Chapter 1.8. Solve rational inequalities. So far we have done, I did on the inequality part, we saw linear inequalities, then what else we saw? Compound inequalities, right? And then we saw inequalities with absolute values, right? And we saw quadratic inequalities the last class meeting. So you can like organize all these type of inequalities you've been solving, okay? So you have to have a really good knowledge of all that to solve what we are going to do today, okay? So how many things we have done? Linear inequalities the first day, right? And then compound inequalities, and inequalities with absolute values, right? And yeah, higher power polynomial inequalities, what we did, right? Quadratic or higher power polynomial inequalities we did last class meeting, okay? Okay, so we have these four things here. So today we are going to do under solving inequalities. So today this is the fifth one we are doing. You can make a note of that, okay? All right. So what is rational inequality? So this rational means it's not just, rational means it's fraction, but what we are going to do, rational, the fraction in the denominator, we are going to have variables. For example, we are going to do something like this. 2x plus 1 over x minus 3 less than negative 2. This is a rational inequality. Why we call this is a rational inequality? Why are we calling this is a rational inequality? This whole thing together? Why?
They have the variable in the denominator?
We have a denominator part in the problem, right? Whenever we have a denominator part in the problem, we call rational equations, right? Remember the first day of class, I solved that big rational equation with three algebraic fractions, right? 3 algebraic fractions in the denominator. You guys know how to already solve rational equations. You already know. Big ones, like what I did the first day, example number 1. So this is also called, this is a rational part. This is the rational part. In this rational part, we are not just having a 4 or just one whole number, one like a numerical only. We also have what? A variable. Okay? So we have variable, and this is an inequality, and this is what we have. Okay? Now, let's go. We are supposed to solve this. So solving means, because it's a rational inequality, and rational means we have variables in the denominator, and if we solve this by cross multiplying, it's going to be very wrong. You cannot cross multiply here. Because it's an inequality, we cannot cross multiply. The reason to that is when you cross multiply, let's say we don't know the value of x, right? X can be a positive number or negative number. So if you multiply, let's say because this whole thing become a negative number based on what the value of x, and if you multiply something by a negative inequality by a negative number, what will happen to this inequality symbol? It's supposed to switch, right? So we don't know what's exact value for x, therefore we can't just cross multiply. So we can't cross. So what else we can do? We cannot cross multiply with inequalities. If there's an equal sign here, of course we can cross multiply and solve this. With inequality, we cannot cross multiply. Okay? So what else we can do here? What do you think we should do? Yes, we need to bring the negative 2 to this side. So this becomes 2x plus 1 over x minus 3 plus 2 is less than 0. So this is first step. Bring everything on the right hand side to the left hand side and make equal to 0. Just like we solved polynomial inequalities. Remember we solved polynomial inequalities last class meeting and we did this. This is our first step. After this, the next step. Now together we are going to simplify this. And we know how to do that. What's the common denominator? X minus. We are not going to multiply the whole inequality by x minus 3. We are just going to simplify this side, like adding two fractions. Just this side only. Okay? So what do we get? X minus 3 is the common denominator. So we get 2x plus 1 over x minus 3 and plus 2. So this fraction also need to be multiplied by x minus 3. I mean this 2 has to be multiplied by x minus 3. So I have 2 there, 2 need to be multiplied by x minus 3. You see that? Is less than 0. Okay, now under the same denominator, what do we do? Combine the numerators. This is part of simplified rational expressions, right? So this is 2x plus 1 plus 2x minus 3. Are we good?
Minus 6.
Minus 6 over x minus 3 Okay guys, from here, what do you need to do? Simplify the numerator again, right? Simplify the numerator, we get
4x minus 5.
4x
Minus 5.
minus 5
Yeah.
over x minus 3 less than 0. So here we go. So that's how we can simplify. You simplify all the way. Okay? Now we need to do something important here. If this was a polynomial, remember we did polynomial without anything in the denominator. Polynomial inequalities, at this point what did we do last class meeting when you guys did the homework problem? What we supposed to do at this point?
Factor.
We factor these and then in the process what are we doing? What is our objective here? What is our plan? Find the x-intercept. So we are doing factoring some cases to find the x-intercept, right? But this case we don't have. So here we find the x-intercept in the numerator, and also we need to look at this as we can also call this x-intercept, find the x-intercept. So we solve for x here, solve for x here. Here actually later on you guys going to do this. This whole thing is a rational graph. Now rational graph you don't have to learn right now how to graph this whole thing. Remember when we had polynomial graph, I showed you how to graph the polynomial one, right? The first one. But this one is also just like the quadratic graph. This is also some sort of graph. Later on you're going to learn how to graph this. Here what happened when x equal to 3? No solution, right? X equal to 3, the graph is going undefined. The graph is undefined. So at x equal to 3, we are going to, we have is called asymptotes or vertical asymptotes. You're going to learn this later. We don't have to worry about the graph. I did talk about it when we were also solving polynomial fractions. Okay? I mean polynomial inequalities. However, I want you guys to kind of think that you know this is some sort of graph, right? That's how I want you guys to see. Book is not mentioning all that in detail, but I always want you guys to see this as a big graph. Graph means it's on the coordinate plane, it's going up and down, some curves and some lines, right? Alright, so now the next step is find the solve for x in the numerator and solve for x in the denominator. So what is x here? 4x is equal to 4x minus 5 is equal to 0. X is equal to 5/4. So we have one x value. And here x minus 3 is equal to 0, x equal to 3. So we have, so these are the two x values so far. So when we have these two x values, next thing is we only need to do the line test. We are going to do the line test. So now the line test. So this is easy because we have done polynomial inequalities last class meeting, so it's the same thing so far, right? Except we have a denominator expression. That's the same thing. Okay, so we need to mark the points 5/4. So what is 5/4? 1 and 1/4?
Yeah.
Sometimes some numbers are going to be fraction, they are not that user friendly, but we have to work with it. Okay? Always you are not going to get integers. Okay? So what is this? 5/4 is 1 and 1/4, so this is 0, 1, 2, 3, 1 and 1/4 is somewhere here. When x is equal to 1 and 1/4, the numerator is 0, right? If the numerator is 0, and this is the whole of this fraction going to be what?
0.
This is 1 and 1/4, 0. But so this inequality says 0 is less than 0, right? So, but we cannot, we are not going to, it's only, we have to take only less than value, right? So we don't take the 0. Do you understand? We only take the, because if it says equal, then 0 is equal to 0, we consider the 0 value. Just like the way we consider polynomial inequalities. We have equal sign, we use that 0. So here, 1 and 1/4, 1 and 1/4, is it open or closed?
Open.
Open. 1 and 1/4 is open. 1 and 1/4 to x equal to 0. This is open. Other value is x equal to
3.
3. X equal to 3. X equal to 3 here. Now at x equal to 3, what's happening to the inequality? What happening to the left hand side, to the graph? We discussed this before, x equal to 3. The denominator is 0, right? So what happened, any number divided by 0 is undefined, right? So this is undefined x equal. So when you do the graph, I mentioned it's called a vertical asymptote, but we don't have to worry about it. Whenever we have the value of the variable in the denominator that makes the denominator goes to 0, that point is always open. This is always open point. We can't use 3. At 3, the graph is undefined. We don't know where the graph is going. So this point is always 3. Okay? Always open, sorry. This point is always open. This point is open because of the given inequality. Okay? So we know that. So now how many intervals we have? This is only the 2 points we have to consider, right? How many intervals we have according to the line
2.
test we have? How many? 3 intervals. We have 3 intervals. On these 3 intervals, we have to check how the graph is going. Whether above x-axis or below x-axis. That's one. Or so we are going to test point. So get your test point and check. So Pick a test point here.
0.
0. So x equal to 0, and when x equal to 0, what will happen to 4x minus 5 over x minus 3?
100.
What is going to be? This is 0, minus 5, minus, right? So minus and a minus is negative divided by negative is positive. So this is positive. So at x equal to 0, at this interval, we get a positive value. Positive value is not less than 0, right? You see, this value doesn't satisfy this inequality. Do you see that? These values, any of these values is not a solution to this, because we get a wrong, we don't satisfy the given inequality. Therefore, we don't have any solutions here. Or the way we did in the other, when we did polynomial inequalities, what I did is I wrote the sign here, right? Positive, 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 like that, all the way up here, right? So we know positive part is, this is positive, and 0 is not greater than a positive number. So we can't use this, right? Okay, next, we need to look at any number from here to here. Which one you're going to use?
2.
X equal to 2. X equal to 2. So now check on this again. What's the sign going to be? 8, positive, negative. Positive divided by negative is? Negative. So this is negative. So here's the negative signs, negative all the way to here. Then we are going to look at x equal to, the next test point is x equal to
4.
4, yeah, x equal to 4. What is it going to be?
Positive.
16 minus 5 positive, 4 minus 3 positive, positive divided by positive is positive. You don't have to show the work here, but just show that the points you took and what signs you get. Okay? And you can label these signs here. Now according to the graph, according to this, can we take any positive solutions where the graph is positive? This says always graph supposed to be negative, right? This graph is less than 0. The inequality says the graph has to be less than 0. Therefore, we only consider x values where the graph is less than 0. The inequality says solve this inequality, solve for x where the graph is less than 0. That's what we are doing here. Solving for x where the graph is less. So what values of x where the graph is less than 0? See, graph is negative this area only. Okay, so, and this is open because if we have equal sign here, this is just like what we did before last class meeting, right? We consider this closed also. This is open. This is always open. All the values of the variables in the denominator where the denominator makes to 0 is always open. Okay, so what is here? So this is where our final solution going to be. Final answers. All the x values are in this location only. So now we have the line test. So final answer. Final answer. 1 and 1/4 to 3. Close or open? Open. Open. Right, guys?
Yes.
Graph 1 and 1/4. You can put a open circle or you can put parentheses, and 3 parentheses. So this is, we need to give this to Any questions, guys? Now, you're going to have 2-3 problems like this on the test, okay? You have to know how to solve polynomial inequalities and rational inequalities. This is big time. You guys can do this. You guys, all of you guys can do this. Any question, David?
You know how when we got 3 as one of the x values, but if you plug in 3 to the denominator, it would go 0. When will it count to where we can't use that number that will make the denominator 0?
Yeah, so that's,
Sometimes-
I kind of mentioned that, I will repeat this again. Whenever you have a rational inequality with variables in the denominator, right? There are restrictions for the variables, right? We discussed this as restrictions before. So at these restrictions, in case this one is when x equal to 3, the denominator goes to 0, right? So we cannot use 3 if we are doing a regular simplification. We are going to say x equal to 3 is a restriction and we are going to continue with the problem, okay? But here, we are going to, what we are going to do is, we are, as a part of the procedure for solving this problem, this inequality, we need to solve for this. X equal to 3 is part of our problem. We need to get this. We can't just drop this, okay? Even though it's undefined at x equal to 3, we have to use it. But we are telling ourselves, we are not going to, so this is an open circle. We are telling ourselves we are not going to use 3. 3 is not part of the solution. See, we have taken out 3. Everything, every other number right after 3 is part of the solution. Onto this side, not to this side. Okay, so basically 3 we are not using, okay, because at 3 the function is undefined.
The last question.
Okay.
So if it was less than or equal to, like the same problem, it would be brackets 1, 1, 4, 3 parentheses, because you
No,
still.
if you have, still we don't use 3. Good question.
So
Still we don't use 3. At 3 the function. So always at 3 in this case, at 3 it's open. But if you have less than or equal here, this part is equal because the numerator is equal to 0. Okay? Okay, so you guys see that, right? That's what we did last class meeting. We did like 4 examples where there's equal sign also. Okay? Okay guys, I'm going to do a couple more problems a little fast now. And any questions from this? No? Okay. Easy, right? Very easy, because it's easier because you guys are good with what we did last class meeting. Okay? If you didn't have an idea what we did last class meeting, this is kind of little abstract. And when I did last class meeting problems, I explained in more detail how the graph, what it did, what it means, like a lot of stuff, right? So this one, okay, so let's do some problems from the book. So I'm going to do problem number 48. Number 48 and number 54. So this is my I want to do at least these 2 problems, so we have 3 problems. Yeah, so let's do 48 and 54. Okay guys, so let me do one more problem. I'm just going to do real fast this problem. So I just want you guys to do little challenging problem, right? This is same thing, this problem number 54. What do we have? 3x over x minus 1 less than or equal to x over x plus 4 plus 3. So let's do this. So when we do problems like this, we are like, it's the same simplification, we are like working with little more challenging, right? Little harder, okay? So it's okay, you guys are familiar with the procedure now. So this is just Very easy, you guys will do it, okay? So what do you do? 3x over x minus 1 subtract x over x plus 4 subtract 3 less than or equal to 0. Common denominator.
X minus 1, x plus 4.
First thing we need to multiply by first fraction. First fraction we need to multiply by x plus 4, x plus 4. Second fraction, x over x plus 4 multiplied by what?
X minus 1.
X minus 1 and x minus 1, correct?
Yes.
Minus 3 multiplied by what?
X plus 4.
We need to multiply by x minus 1, x plus 4 over x minus 1, x plus 4. See, the denominator has to be same for all these three sections, right? So here we have 3, we want the same denominator, we have to multiply the numerator with the same two things here and the denominator also with these two factors. Okay? Less than equal to, is it less than? Yeah, less than equal to 0. Are we good? Okay, so now we are going to simplify. This is just simplify algebra, basic algebra. So simplify real fast. We get 3x squared plus 12 minus x squared plus x.
12x.
Oh, 12x, thank you. Yes.
Oh, right, yeah.
Minus x squared minus minus
Positive x.
positive x. Now here we need to multiply these two first. So this is going to be x squared minus plus 4x minus x minus 4. So that's going to be x squared. So this is minus 3x squared plus 4x minus x is plus 3x and times negative 3 is negative 9x minus 4 and minus 3 is minus minus plus
Plus 12, yeah.
less than or equal to 0 over the same denominator x minus 1 x plus 4. So this is how we subtract algebraic fractions, right? We keep the same denominator. Alright, the next step we need to simplify the numerator. These get cancelled. Negative x squared. What do you get here? 30 minus 9 is 4 plus 12 over x minus 1 x plus 4 less than equal to 0. Okay guys, now we need to get the zeros, right? Now here we have a quadratic equation. We know how to solve a quadratic equation. And we are supposed to have a positive here, right? It will be better if we make this. So we can what? What do we need to do now? Multiply the whole inequality by negative. So let's multiply the whole inequality by a negative 1. Okay? So what happened? X squared minus 4x minus 12 over, so when you multiply by negative, I'm only multiplying the numerator by negative 1. I mean this side by negative 1, so that negative 1 I put on the numerator. Okay? X minus 1 over x plus 4. Now, what do I need to do? Now we need, because we multiply the numerator by negative 1, we have to switch the inequality symbol. So you are doing some things that you didn't do in the other two problems here. Okay, so now we need to factor here. Let's factor here fast. See, we are doing a lot of things here.
X minus.
We are doing a lot of things here.
X minus 9.
x minus 6 and
X plus 2.
x plus 2. Very good, class. Okay, now we are going to find the zeros. What are the zeros of x? Zeros of the function, zeros, and the undefined.
6.
Our values of x, right? So x is equal to what? 6, the graph is 0, x equal to negative 2, and x equal to 1, and x equal to negative 4. Now, these two are restrictions, right? So we know these two graph is undefined, open. These two at x equal to 6, graph is equal to 0, right? If you substitute x equal to 0, this is a number in the numerator, denominator becomes 0, 0 times any factor is 0. So 0 is equal to 0, so 6 is close, right? 6 is close, and what else?
Negative 2 is close.
Negative 2 is negative 2 close as well?
Yes.
Yes, negative 2 close as well, because at negative 2, the numerator is equal to 0. 0 divided by any number is 0, right? And the equal sign. So these two are, so let's go from, when you label these points, label from lowest to highest on the number line. What's the lowest number? Negative 4, and then negative 2, and then 1, and then 6. Okay, so these are the numbers. At negative 4, graph is undefined, so we go there. At negative 2, graph is, we can use the point negative 2. This is a solution. At negative 2, see? At negative 2, this is 0. We talked about this many times now. At 1, open, undefined, graph is undefined. At 6, close, because the graph is 0, 0 is equal to 0. So this is a solution. We already know the closed points are solutions. Okay? Okay, now 4 intervals. So we are going to, these are test points. So test points. Test points, what happened with the test, what are the numbers with test points?
Negative 5,
Negative 5,
negative 3,
negative 3,
0,
0, 5. How many intervals?
5,
5 intervals, right? So if it's 5 intervals, 5 test points. 7. So here we have 5 intervals. So that's a lot of work. See, you are responsible for a lot of work. You're doing it right. Okay? So, okay. So let's check. What do you guys think? Let's do this problem real fast, guys. I'm sorry. Positive? So we are checking for this whole factor, right? X minus 6 times x plus 2. This is a rational function. Is the function going to be positive or negative? Above the line or below the line, right? This is a graph. You guys will graph this later on. Okay? Okay, so what is here? Positive? Positive here and negative here. Positive here, negative here, positive? You got it? Okay, very good, very good. So everybody agree to this? Okay, so now we are done, right? Final answer. We have to look where the graph is negative, right? So the solutions are from here to here to here, graph is, we have to, only solutions are graph is positive. These will satisfy, these solutions will satisfy the inequality. These solutions will satisfy the inequality, right? So now, how many solutions? Negative infinity to negative 4, open, union. Is 2 close, guys?
Yes.
2 to 1, open or close?
Open.
Open, oh yeah, negative 2, thank you. And then what?
6 to infinity.
Union, 6 to
Infinity.
infinity, 6 to infinity, open, 6 is open or close?
Close.
So if you guys see this open, close, this means If you don't put close, that means one solution is missing. So it's wrong. When we find solutions, we have to find all solutions. We talked about this last class meeting also. All solutions where this inequality satisfies. All values of x where this inequality satisfies. So you guys good? Okay guys, homework. So we did 3 problems similar. You guys did really good. Thank you. Alright, so my classwork, homework assignment number 6. All homework is due Monday. We are going to do problem number, where was it? 41 through 50. 50? Yes. Homework number 6, 1.8, number 41 through 50, all. I did 3 problems, yeah, I did 2. I did 2. Maybe 50, let's do till 52, sorry, 52. Okay? Any questions you can ask me? I'm going to give like. Sorry? Yes, yes, because that way you are ready for the test. So you have the weekend, please study during the weekend, everything that you're supposed to know, right? Look for practice tests on Canvas.